In the world of data science, Python stands out for its ease of use and powerful data analysis capabilities. Reflecting on the 2023 Stack Overflow Developer Survey, Python's popularity is unmatched, especially among data analysts and scientists. Consider the success story of Anna, a data analyst whose expertise in Python's Pandas and NumPy libraries led to the development of a predictive model that significantly influenced her startup strategy. This example highlights Python's practical application in extracting meaningful insights from data, a skill highly valued in the industry. As you gear up for a Python data analyst interview, it's crucial to demonstrate not only your technical mastery of Python, but also your ability to apply its functionalities to real-world problems. This guide focuses on essential interview questions and answers, drawing from real-life applications and challenges to prepare you for what lies ahead. Through understanding practical use cases like Anna's, you will gain insights into the impactful role Python plays in data-driven decision-making. And before we move on, guys, just a quick info for you. So we'll start with the first question, that is, what is Python and why is it preferred for data analysis? So Python is like a versatile tool that's not only easy to use but also powerful enough to tackle big projects. It's a programming language, which means it's a way for us to write instructions that a computer can understand and execute. What makes Python special is how it combines simplicity and power. It's as if the tools in this section of the supermarket are designed to fit comfortably in your hand and work exactly as you expect, making your job easier. So here I will be giving you an overview of the answers you can provide to the interviewer in the interview. So now you might wonder, why do people working with data love shopping in the Python section so much? So let's consider some points for that would be easy to learn. So Python's simplicity means you can learn how to use it quickly even if you are never programmed before. It's like learning to cook using recipes that requires only a few ingredients. Then comes versatile toolset. Python offers a variety of tools known as libraries, specifically designed for data analysis. Imagine having a Swiss Army knife but for data. These tools can help you clean, sort, analyze and visualize data all in one place. Then we have community support. So there's a huge community of people who use Python for data analysis. So if you ever get stuck or need advice, there's a good chance someone has been in your shoes and can help. It's like having a group of friends who are always there to lend a hand. And then comes integration and automation. So Python makes it easy to automate repetitive tasks and integrate your data analysis work into larger projects. This can save you a ton of time and effort, allowing you to focus on the fun parts of your project. Then comes the in-demand skill. Because so many businesses rely on data to make decisions, knowing how to analyze data with Python is a valuable skill that can open doors to exciting job opportunities. So this is how you can answer the interview about why is Python preferred for data analysis. So moving to the next question, that is, explain the difference between a list, tuple and dictionary in Python. So I will give you an overview. You could use this or just mold it to your language and provide the answer to the interviewer. So when discussing the structures, that is list, tuple and dictionary in Python, it's like looking at different ways to organize information. Each serves a unique purpose. Lists are akin to an adjustable shelving unit. You can add, remove or change the items on freely. It's ordered, meaning you can refer to each shelf by its position. For example, you could see an example here, that is my underscore list, and we have put pencil, notebook and eraser in the list. So it allows you to manipulate the contents as needed. Now coming to the tuples. So tuples resemble a fixed display case. Once you have arranged your items inside, their order and presence are set. You cannot change them. This immutability is useful for ensuring that certain data remains constant. So you could see the example. So I have changed the example. So you could see here that my tuple has pencil, notebook and eraser. So it signifies data that you don't intend to alter. Now coming to dictionaries, so they are like a flying cabinet or the filing cabinet with labeled folders. Each folder or key holds specific items values, making it easy to locate what you need quickly without concern for the order in which you added them. So you could see an example, that is my underscore dictionary that has pen and it is pointing out for the blue. Then book, that is pointing out to mathematics. That provides a way to access items directly by their label or key. Now moving to the next item or the next question, that is, how do you handle missing values in a Pandas data frame? So when working with data in Python using Pandas, it's common to encounter missing values. Think of missing values like puzzle pieces that are lost. To complete the puzzle or analyze your data, you need to decide what to do with these missing pieces. So strategies to handle missing values. The first one will be remove. So if the missing value is like a lost puzzle piece that isn't crucial, you can simply remove that row or column. This is straightforward but can lead to losing valuable information if not done cautiously. For example, you could just use df.drop_na. So this is how you could use it. Now coming to the next option, that is fill in. So if you think of the missing piece as something you can guess or approximate, you can fill in the missing value with a guess. This could be the average of the order pieces, the most frequently appearing piece, or a placeholder like 0. For example, you could use df.fillNA and you could pass the value inside it. So the choice between removing and filling in depends on your specific dataset and what you are trying to achieve. If maintaining the integrity of your data without the missing pieces is crucial, filling in might be the best option. If the presence of incomplete data could skew your results, removing those entries might be safer. So this is how you could tackle this. Now moving to the next question, that is, what are lambda functions in Python and where would you use them? So imagine you are in the kitchen about to make a quick snack. You could pull out a big food processor for a small job, but sometimes it's easier to use a simple knife. In Python, lambda functions are like that handy knife, a quick one and a one-time tool for small tasks. So let's understand the lambda function. Lambda functions are small anonymous functions defined within the lambda keyword. They can have any number of arguments but only one expression. Perfect for when you need a simple function for a short period. You could see the syntax, that is basic form, lambda arguments, expression. Now we'll see its examples of use. Number one is sorting. Imagine you have a list of names with their ages and you want to sort them by age. Lambda function makes this simple. So you could see the code here, that is sorted, and under we have passed list, key equal to lambda x of 1. So this is how you could do that. Then comes the quick calculation. So you need to quickly apply a mathematical operation like squaring a number without writing a full function. So you could have a example here. So this is how you could have a square of a number. So when to use lambda functions? So now we'll see when to use lambda functions. Number one is short one-time use. That is ideal for when you need a function once or in a limited scope. And number two would be simplicity, when the operation is simple enough to be expressed in a single line. And then comes the inline operations, that is useful for inline operations that requires a function. So let's move to the next question, that is question number 5. And the question is, demonstrate how to use list comprehension to simplify code that generates a list of square for all even numbers from 0 to 10. So imagine you are tasked with creating a beautiful garden path using square stepping stones. However, you only want to use stones that fit certain criteria, such as being even numbered in size. In Python, list comprehensions offer a concise way to create this path with just the stones you need. So let's understand list comprehension. So list comprehension provides a succinct way to create list. They combine a loop, conditionals, and the list operation into one line. It's like selecting specific items based on criteria to create a new collection. And now we'll see the basic syntax for that. That is, in the form, you will write the expression for item and then the iterable and if condition. So let's see an example. So we'll create a list of square for all even numbers from 0 to 10. So first we'll do this with the traditional approach. And here we have an array, and then we'll use the for loop and then if statement, and then we'll append if the number is even, we will square it. Now coming to the list comprehension approach, so you could see the expression here. So first is the condition, then the for loop, and then the if conditional. So this is how the list comprehension works. So now we will discuss about the key points of list comprehension. So the number one is efficiency. So list comprehensions make your code more readable and efficient. Number two is simplification. They simplify multiple lines of code into a single readable line. And then comes versatility, useful for filtering items or applying operations to elements. And now coming to the next question, that is sixth one. Explain the concept of deep and shallow copy in Python. So imagine you have a magical notebook. Whatever you write in it also appears in a linked notebook. If you have a shallow copy of the notebook, changes to the content like adding a new page in one will show up in the another. However, if you change something on a page already existing in both notebooks, only the original notebook's page is affected. A deep copy is like having two completely independent magical notebooks. Whatever you do in one notebook, whether adding new page or changing existing ones, doesn't affect the other notebook at all. So let's understand shallow copy and deep copy. So shallow copy creates a new object but does not create copies of nested objects found within. Instead, it just copies the reference to these objects. So changes to nested objects in the original or the copy will reflect in the other. So you could see an example for that, that is import copy, and then we have the original list, and the shallow copied list is equal to copy.copy of the original list. Now moving to the deep copy, so it creates a new object and recursively copies all objects found within the original object, nested objects included. So changes in the original or the copy do not affect each other at all. So let's see the example, that is deep underscore copied underscore list equal to copy.deep copy, and inside we have passed original list. Now we'll discuss about the key points. So shallow copy, that is good for saving memory when creating copies of large objects where nested objects aren't modified. And about the deep copy, so it used when you need a fully independent copy of an object, including all nested objects. So this was about deep copy and shallow copy. Now moving to the next question, that is what is PEP8 and why is it important in Python programming? Imagine you are playing a game where everyone agrees on certain rules to make the game more fun and fair for everyone. In the world of Python programming, PEP8 serves a similar purpose, but for writing code. PEP8 stands for Python Enhancement Proposal 8, and it's essentially a set of rules and guidelines for formatting Python code. So let's understand PEP8. So PEP8 is like the rulebook for Python code style. It covers recommendations on how to format your code, such as how to name variables, how to indent your code, and other best practices. Think of it as the etiquette for Python programming. Ensure that everyone writes code in a consistent and readable way. And let's discuss why PEP8 matters. So the number one reason is readability. Just like a well-organized book is easier to read, code that follows PEP8 is easier for humans to understand and read. It's about making your code not just functional but also presentable and approachable. Then comes collaboration. When everyone uses the same style guide, it's much easier to work on projects together. This consistency removes confusion and helps prevent errors that arise from misinterpreting the code. And then comes maintenance. So code that's easy to read and understand is also easier to maintain and update. If your code follows PEP8, anyone including future you can quickly understand and modify it as needed. So following PEP8 is like keeping your code's desk clean and organized. It makes your Python programs more enjoyable and easier for you and others to read and work on, just as playing a game is more fun when everyone knows and follows the rule. Coding in Python is more effective and enjoyable when everyone adheres to PEP8. So this was about PEP8. Now moving to the next question, that is describe how to perform a merge operation between two pandas data frames. So imagine you are at a dinner party and you have two guest lists. One list has the names of guests and their favorite dishes. The other list has names with their preferred drink choices. To plan your dinner menu, you need to combine these lists into one. So you think each guest food and drink preferences side by side. In Python's Pandas library, this combining of lists or tables is called a merge operation. So let's understand merge in Pandas. So first we'll see Pandas. So it's a powerful library in Python for data analysis and manipulation. And merge operation is like joining two tables based on a common column, like guest names in our example, so that you can see all the information in one place. So let's see the steps to perform a merge. Number one step is identify the common key, that is find the column common to both data frames such as guest name. Then choose the type of merge. Decide how you want to combine your list. Do you want to include all guests, only those present on both lists, or some other criteria? And then use the merge function. Apply Pandas merge function to bring your data frames together based on your criteria. You could see the example here. That is, first we will identify the common key and then we'll choose the type of merge, as you could see, like outer join, inner join, or both the criterias. And then we have used the merge option. So this is done. That is to perform a merge operation between two pandas data frame. Now moving to the next question, that is ninth question, and that is, can you explain what NumPy is and how it is better than a regular list in Python? So imagine you have a toolbox. In this toolbox you have a regular hammer, that is Python's list, and a power hammer, that is NumPy. Both can drive nails into a board, that is perform numerical operations, but the power hammer does it faster and with less effort, especially when you have a load of nails, large dataset. NumPy stands for Numerical Python and it's a library especially designed for numerical operations. It introduces an object called an ND array, that is n-dimensional array, that is more efficient than Python's regular list for a few reasons. Now we'll see those reasons. Number one is performance. So NumPy arrays are stored at one continuous place in memory, allowing faster access in comparison to list. So this means operations on NumPy arrays can be done much quicker than on list. Then comes functionality. NumPy comes with a vast library of mathematical functions that can be performed on arrays, making it incredibly powerful for scientific computing. And then comes memory efficiency. A NumPy array is more memory efficient than a list, allowing you to work with larger dataset. So this is why NumPy is better than a regular list in Python. Now moving to the next question, that is how do you improve the performance of a slow running Python script? So imagine you are in a race with a backpack full of tools you think you might need. As you run, you realize the backpack is slowing you down. So to speed up, you would streamline your backpack, carrying only what's essential and organized for quick access. Optimizing a Python script follows a similar principle. So here's how. Number one is profile before optimizing. First, find out where the heavy items are. Use profiling tools to identify the slow parts of your script. It's like checking your backpack to see what's making it too heavy. Then you can use efficient data structures. Some data structures are faster than others for certain tasks. It's like choosing a lightweight, compact multi-tool over carrying separate tools for each job. You could leverage NumPy for numerical tasks. If your script does a lot of mathematical calculations using NumPy, as we discussed earlier, you can significantly speed things up, similar to swapping out a manual tool for a power tool. And then you could avoid global variables. Accessing global variables is slower than accessing local ones. It's akin to having the tools you frequently use in an easily accessible pocket rather than in the bottom of your backpack. And you could use built-in functions and libraries. Python's built-in functions and standard libraries are optimized for speed. Using them instead of custom solutions can be like using a well-paved road instead of hacking your way through the jungle. And then you could use limit of loops. So loops, essentially nested ones, can slow down a script. Where possible, use Python's list comprehensions or NumPy's vectorized operations. It's like choosing a path that goes directly to your destination instead of wandering around. So by focusing on these strategies, you could significantly improve the speed of your Python script, making your coding race more of a sprint than a marathon. Now moving to the 11th question, that is what is the purpose of the group by function in Pandas, and provide an example of its use. So let's say you have a big box of crayons sorted by color. You want to count how many crayons you have in each color. In Python's Pandas library, the group by function helps you do exactly that with your data. So the group by function groups data in a data frame based on a certain criteria, like how you might group crayons by color. So once grouped, you can apply functions to each group independently, such as counting them, summing up values, or calculating averages. So here how it works. Number one is group. So the first group by that separates the data into groups based on your chosen criteria. It's like sorting your crayons into groups of the same color. Now coming to the apply, so next it applies a function to each group. This could be calculating the average, sum, count, etc. If we are sticking with the crayon analogy, this is like counting how many crayons you have in each color group. And then comes combine. Finally, it combines the results into a new data frame. You end up with a summary of your original data organized by the grouping criteria. So it's like having a neat list that tells the count of each color of crayons. So now moving to the next question, that would be 12th. So how can you create visualizations using Matplotlib or Seaborn? Provide an example. So imagine you have just taken a beautiful hike and you want to share the experience with your friends. You could describe every detail in words, or you could show them a photo that captures the essence of the adventure. In data analysis, Matplotlib and camera and filters for data, allowing you to create visual representations that capture the insights from your dataset. So talking about Matplotlib, that is the camera. So Matplotlib is a plotting library in Python that allows you to create a wide range of static, animated, and interactive visualizations. Think of it as your camera for data visualization, giving you the tools to create basic graphs like line charts, bar charts, and scatter plots. And then comes the Seaborn. But before that, you could see the example here, that is import Matplotlib as PLT. Then we have X and Y, and they have the numbers there, and then you could plot the graph there. And then comes the Seaborn, the filters. So Seaborn is built on top of Matplotlib and provides a high-level interface for drawing attractive and informative statistical graphics. So Seaborn is like adding filters to your photos, making your visualization more aesthetically pleasing and easier to interpret with less code. And you could see the example here, that is import cbone as SNS, and then you could set the theme and the line float. Now coming to the next one, that is 13th question. So now guys, let's understand overfitting. So overfitting occurs when a machine learning model learns the details and noise in the training data to the extent that is performs poorly on new data. It's like memorizing the answers to a test rather than understanding the subject. And now we'll see how to prevent overfitting. So number one is use more data. So having more data can help the model learn better and generalize well. It's like learning more about types of fruit to improve your overall understanding. Then comes simplify the model. Sometimes using a simpler model can prevent overfitting. This is akin to focusing on the basic characteristics of fruit like color and shape rather than memorizing every spot on the apple's skin. And then comes cross validation. This technique involves rotating the dataset through training and validation phases. It's like practicing with different sets of fruit every time to ensure you really understand them, not just memorize them. And then comes regularization. So this technique adds a penalty on the more complex features of the model. Think of it as discouraging the model from paying too much attention to the less common characteristics of the fruit. And then comes early stopping. During training, if you notice that your model's performance on a validation set starts to worsen, stop the training. It's like realizing you are starting to focus too much on the details that don't matter and stopping your studying to refocus. And in conclusion, overfitting is like studying too hard on the specifics and missing the big picture. By using strategies like gathering more data, simplifying your model, and practicing with cross validation, you can help your machine learning model to learn better and be more adaptable. Just like a well rounded student who understands the essence of the subject, not just the details. Now moving to the next question, that is 14th. Describe a situation where you had to clean a large dataset and what steps did you take? So imagine you have just been given a giant old attic full of various objects to organize and clean up. Some items are valuable and need to be kept, some are duplicates and others are just plain junk. Cleaning a large dataset in Python is somewhat similar. You are aiming to tidy up the data so that it's useful for analysis. So we'll see the steps for cleaning a large dataset, that is remove duplicate data. That is just like removing duplicate items in the attic that you don't need more than one of. In datasets, duplicates can skew your analysis. So for that, we'll use the action as we have seen the number one step, that is remove duplicate data, and we'll see the action, that is we will use dataframe.drop underscore duplicates in pandas to remove them. And then we can use another method, that is handle missing values. So imagine finding boxes that are supposed to contain items but some are empty. You decide whether to fill them, label them as empty, or remove them altogether. For that, we could do the action, that is options include dataframe.fillNA to fill missing values or dataframe.dropNA to remove rows or columns with missing values. And then we have correct data types. Sometimes objects are stored in the wrong boxes. Similarly, a numeric column might be incorrectly formatted as text. So for that, we'll use dataframe.asType to correct data types. And then we have standardized the data, ensuring everything is organized and labeled consistently, like making sure all book titles follow the same format. For this action, we will apply functions to clean and standardize text, numbers, and dates. And we have remove or correct outliers. If you find something completely out of place, like a snowboard in a box of summer clothes, you decide if it's an error or if it should be stored somewhere else. So the action we can use is use statistical methods to detect outliers and decide whether to keep, adjust, or remove them. And in conclusion, cleaning a large dataset involves removing unnecessary parts like duplicates and outliers, filling in gaps, that is missing values, and organizing, correcting data types, and standardizing. It's about making sure the data is accurate, consistent, and ready for analysis, just as organizing and cleaning the attic that makes it easier to find and use what you need. Now moving to the next question, that is 15th. How do you split a dataset into training and testing sets using scikit-learn? Imagine you are preparing for a magic show. Before performing in front of a live audience, you practice your tricks with a friend to get feedback. Similarly, when you are working with machine learning models, you need to practice or train your model on a portion of your data and then test it on another portion to see how well it performs. So this process helps ensure your model can perform magic with new, unseen data, not just the data it learned from. So we'll see using scikit-learn to split data. So scikit-learn is like your magic kit for machine learning in Python. It has a tool called train_test_split that makes dividing your data into training and testing sets a breeze. So we'll see the steps to split your dataset. Number one is prepare your data. Gather your dataset. It's like getting all your magic props ready for the show. Then import the tool. Bring the train underscore test underscore split function into your project. And then we have split the data. Decide what portion of your data you want to train on and what portion to test on. The common split is 80% for training and 20% for testing. And you could see the code here. And here X represents your features, that is the information you use to make predictions, and Y presents your target, what you are trying to predict. And then we have text size equal to 0.2 that tells the function to reserve 20% of the data for testing. And in conclusion, splitting your data set into training and testing sets is a crucial step in the machine learning process. It's like rehearsing your magic tricks before the big show, ensuring your model is well prepared to amaze with its prediction on the new data. Using scikit-learn's train underscore test underscore split, this process is simple and straightforward, allowing you to focus on perfecting your model's performance. That is 16. Explain the difference between supervised and unsupervised learning with examples. So imagine you are learning to paint. In supervised learning, you have an instructor who gives you a picture to paint and guides you, telling you when you are putting or getting it right and where you need to improve. So this is like having labeled data in machine learning, where you know the correct answers or labels for your training data, and you are trying to predict those answers for new data. So in supervised learning, however, it's like you are given brushes and paints, but no pictures to replicate and no instructions. You are free to explore and create patterns or structures on your own. In machine learning, this means working with data without predefined labels, and the goal is to identify patterns or groupings within the data, such as clustering similar customers together. So key points are here are supervised learning. You have labeled data, and the goal is to learn a mapping from inputs to outputs. And examples include regression and classification problems. So now moving to the key points for unsupervised learning, that is you work with unlabeled data and the goal is to discover underlying patterns or structures. The examples include clustering and dimensionality reduction. Now moving to the next question, that is 17th question. And what are the main steps in a machine learning project? So embarking on a machine learning project is like planning a journey. You need a map to guide you through different terrains and landmarks. And here's how this journey typically unfolds. Number one is define the problem. So first figure out your destination. What do you want to achieve with your machine learning model? And this step is about understanding the problem you are trying to resolve. For second point, gather and prepare data. So next, pack your backpack. You need data for your journey, collects data for your problem, and then clean and pre-process it to make it useful for training your model. Then choose a model. Now choose your model of transportation. Different models like decision trees, neural network, etc. have their strength and are suited for different types of problems. And then train the model. Time to hit the road. Training a model is like teaching it the rules of the road. You will feed it the data you prepared earlier, allowing it to learn from it. And then evaluate the model. Check your map and compass. How well is your model performing? Use separate testing data to evaluate its accuracy and make sure it's learning correctly. And then fine tune the model. So find the best route based on the evaluation, adjust your model's parameters or approach to improve its performance, and then deploy the model. You have reached your destination. Once your model is trained and fine tuned, you can deploy it to start making predictions or insights on new data. And then we can monitor and update. That is, keep an eye on the road conditions. Over time, your model might need adjustment or retraining as it encounters new data or as the underlying data patterns change. So this is about the main steps in a machine learning project. Now moving to the next question, that is how do you evaluate the performance model? So imagine you have baked a batch of cookies for the first time. To know if they are good, you need people to taste them and give you feedback. Similarly, after you have trained a machine learning model, you need to evaluate its performance to see how well it's doing for its job, like predicting outcomes or classifying data. So the steps would be, number one is accuracy. So this is like asking, out of all the cookies, how many were just right? In classification problems, accuracy measures how often the model's predictions are correct. And then confusion metrics. Imagine a chart showing the types of feedback, too sweet, just right, too bland. A confusion matrix help you understand not just the successes, but also where and how the predictions went wrong. And then comes precision and recall. Precision asks of all the cookies we labeled as just right, how many truly are just right? Recall asks of all the cookies that are actually just right, how many did we correctly identify? It's about being correct when you say it's right and finding all the right ones. And then comes F1 score. Sometimes you want a single number to balance precision and recall, especially if you have unsure which one is more important. Type 1 score is like an overall grade for a quick quiz that considers both taste and appeal. And then comes ROC curve and AUC. Imagine plotting a graph showcasing your cookie making attempts, balancing how adventurous you are with flavors against the mistakes you make. So the ROC curve plots true positive rates against false positive rates, and the AUC, area under the curve, gives you a single measure of how good your model is across different thresholds. Now moving to the next question, that is provide an example of using SQL in conjunction with Python for data analysis. So imagine you are a detective trying to solve a mystery. You have a huge room full of file cabinets, your database with information of various cases. Now you need a smart, efficient way to find exactly what you are looking for without rummaging through every file by hand. Here's where Python and SQL join forces to help you out. So the Python and SQL, the detective duo. So SQL is like your search tool for query of the database directly, pinpointing the exact information you need, such as details of a specific case. And you know Python, that is like your assistant detective that helps you to analyze the information, draw insights, and present them in a way that's easy to understand. So now we'll see a simple scenario. You are interested in finding out the number of cases solved each month to see when your team was the most effective. So use SQL to retrieve data. So you write a SQL query to extract the number of cases solved by month from your database. So you could see how we have written here, that is select month and count as case solved, and from case files where status is equal to solved, group by month. So now we will analyze and visualize with Python. So you use Python to connect to the database, run your SQL query, and then use libraries like Pandas for analysis and Matplotlib or Seaborn for visualization. So you could see here that we have imported Pandas and Matplotlib, and then we have connected the SQL here, and then we have run the SQL query and load into a data frame, and then we have plotted the graph. So you could see the example how we have used SQL in conjunction with Python for data analysis. Now moving to the next question, that is 20th question, and how do you handle error handling in Python? And can you explain the use of try, except, and finally blocks? So let's dive in. Imagine you are walking through a forest on a path you think you know well. Suddenly you find a tree that has fallen across your path, and you need a plan to deal with the unexpected obstacle. In Python situation, this is like running into an error in your code. So the try, except, and finally blocks help you navigate these unexpected errors gracefully. So the try block, this is where you walk along your planned path. You place the code that you think might cause an error inside the try block. It's like saying, I will try to go this way, but there might be a tree in my path. And then we are coming to the except block. So if you encounter a fallen tree, an error, the except block is your alternate route. This block catches the error and lets you handle it, preventing the program from crashing. You can specify different types of trees to look out for and different detours. So you could see the example here, that is try walking the path, except, oh no, a tree, take a detour. So you take a detour from here. And then we have the finally block. Whether you encountered a tree or not, the finally block is like reaching the end of your walk and taking a moment to reflect. So this block runs no matter what. Even if there was an error, it's often used for cleanup actions like closing a file or releasing resources. So you could see the code here, that is finally relax at the end. So here's the conclusion, guys. So we have covered 20 questions for you. So if you like this video, please like, share and subscribe. If you have any doubts, comment them in the comment section below, and a team of experts will help you as soon as possible. Until next time, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.